When we expand double brackets, so if we think back to something like x plus 2 and x plus 3, what we're doing whenever we use our FOIL, so we multiply the first by the first, the outer ones, the inner ones, and the last ones together. What we're really doing here is that we are multiplying x by x plus 3. So we've got the x multiplied by the x and the x multiplied by the 3, and we're doing that first. And then to that, we're adding on 2 multiplied by the x plus 3. So that we've got x squared plus 3x plus 2x plus 6, which then would work to x squared plus 5x plus 6. And whenever we're factorising with 4 terms, we basically use this principle, or the fact that if we can get to a stage where we've got 2 terms multiplying the same bracket, then we can express it as those 2 terms in a bracket multiplied by the second one. So if we can get it where the x and the 2 are both multiplying the same bracket, we can basically put that in a bracket and then put the x plus 3 in its own. So this is the reverse process of this expanding brackets. So with 4 terms, four terms like we have in example A, what we try and do is we try and factorise them in pairs so that they have the same bracket. So if we have AX and AY and BX and BY, and we split those into their pairs, what we can see between AX and AY, there's an A common. So we can put an A outside the bracket, and inside the bracket we've got x plus y. The second term we've got BX and BY, so they have a B in common, and then inside the bracket is going to be x plus y. Now what we have now is we have 2 terms in A and B, and they're multiplying a bracket, and those brackets are the same. They're the same in x plus y. So just like we had before, where x plus 2 times x plus 3 was the same as x multiplied by x plus 3 plus 2 multiplied by x plus 3, then if we can work in one direction, then that means we can work back the way. So because these brackets are the same in x plus y, we can then go on and express it as a plus b multiplied by x plus y. And then we've factorised the original expression. So in example B, we do the same idea. So we split them into their pairs, and we need to factorise them. So mk and 2mn, there's an m common, so we'll put that outside the bracket. Then we've got a k plus 2n inside the bracket. Ideally we want the same, so we'll put the k plus 2n, and then we say, well, what do we need to put outside this bracket to get back up to the minus tk minus 2tn? And hopefully we can see that we need to put out a minus t. So minus t times k is minus tk, minus t times 2n is going to be minus 2tn. And now because the brackets are the same, and we've got a term outside each, we can write that as m take t upon k plus 2n. And then in the third example, again, try and split these into their pairs. And in the first common, well, actually, there's nothing common in the first pair of values, and there's nothing common in the second pair. So that would make us think, well, that's not great, we maybe can't factorise this. But what we can actually do is we can just rearrange this expression. So if we put an AB, and then, well, let's put the next term, the third term, the CA beside it, because that way they will be able to be factorised. And then we've got, in the first 2 terms was a positive and negative, so there's a plus dB, let's put it next, so that it keeps in the same form, so dB, and then we're going to be minus CD. Okay, so we've got the positive, negative, and then we've repeated that pattern of positive and negative, and there's something common in each of these pairs. So now, let's pair them off and do simple factorising. So the thing that's common between AB and minus CA is an A, and we'll put in B minus C inside the bracket. Now let's try and repeat the bracket and see if that will factorise. So B multiplied by D is dB, and D multiplied by minus C is minus CD. So yep, those work. And now because we've got the bracket and it's the same, we can then go to our two brackets, where one is A plus D and the other is B minus C. So again, just to go through that again, if we have x plus 5 and x minus 2, whenever we're expanding those brackets using FOIL, we've got x times x, and then we'd do x minus 2. So essentially what we're doing there, we could write it as x multiplied by x minus 2. Then the inner terms and the last terms, so we've got 5 multiplied by x and 5 multiplied by minus 2. And again, the way we could write that is plus 5 multiplied by x minus 2. So because we can get to the stage where in expanding brackets, we can express it as the first term in the first bracket multiplied by the whole of the second bracket, and the second term in the first bracket multiplied by the whole of the second term. So these two lines are now exactly the same thing. So because we're flowing down in this direction, that means then if we ever get to the stage of us having two terms separately but outside of the same bracket, that means we can go back to the double bracket stage. So those two are interchangeable and they mean the same thing. So then that's how we're getting from our first line of our working out to our two bracket stage in the previous three examples.